Welcome to Carbon Conversations, a podcast by Biochar Life, where we explore the cutting edge of environmental solutions. From biochar to smart agriculture to the climate tech revolution, we sit down with experts and business leaders at the forefront of change. This is your host, Matt Rickard. Hey, Annalisa, welcome to the podcast. Good morning or good evening. How are you doing?
Thank you. Doing pretty well here. Thanks for having me.
My pleasure. Cool. It's for me the first one of 2025. So I think it's been about a month. But hopefully you had a nice break and you're back to the lab, I suppose. Would it be in your case?
Yeah. Yes. Well, back to the computers, really. I
Back
don't have a lab. I haven't. Yeah.
Cool. Back to the computer. Well, maybe I won't have done an intro. I know we've been introduced via a third party, and this is interesting for me because we're going to talk about blue carbon, the oceans, and everything related to that from an environmental and conservation point of view. But maybe a good starting point if you'd like to give an intro, your background, what you do, and to set the scene about what we'll talk about.
My background is in physics. I have an undergraduate degree in physics and then a PhD in geoscience more broadly, where I really focused on fluid dynamics. And when it came time to decide where to apply it, I was interested more in the ocean. And I've been working on climate-related problems with a focus on ocean ones through my career.
Cool. Go on, carry on. Sorry.
I was just the main tool I use are models. And so I'm not someone that goes at sea too often and take measurements. I do it once in a while, but really what we do is to run models, trying to understand processes using models and looking at climate in the past, present, and future.
And where do you, so with the research, with the modeling, who are you supporting, in your day-to-day work? Are you supporting the academic community? Are you, what?
I'm a professor at Georgia Tech.
Yep.
In the School of Earth and Atmospheric Sciences. So I'm part of the academic community. We are also trying to work, especially in the last 5 years or so, on more applied projects where what we deliver are also indication of that could be useful to organizations that are trying to develop carbon dioxide removal technologies for the ocean or for ecosystem preservation and restoration as well.
Cool. This is going to be a big question, and maybe it'll kind of unravel lots of areas, but how do oceans drive climate? Can you talk? I know that's a very broad question, but there's a lot in there. And, I watched some of your TED talk, but I think from an audience perspective, like I speak to people in the biochar space all the time. I talk, in forestry. This is the first conversation for me around oceans. I know a fair bit about blue carbon. I've been reading some of the challenges in the space from a carbon removal standpoint. And when I say challenges, I mean, unlocking financing, but it's a lot bigger than that. I mean, talk to us about, oceans and climate and what it means, how it works.
When you're thinking about climate, you're thinking about long time scale. And when it comes to long time scale, the ocean is the one that drives them. So most of the climate variability is really driven by the ocean or is associated with what the ocean is doing. The other very important component that essentially the figure I like to give people who ask that question is if you're thinking about anthropogenic climate change, so how much heat we have put out by burning fossil fuel and increasing the concentration of greenhouse gases in the atmosphere, well, 90% of the heat that is trapped because we have those greenhouse gases has gone into the ocean.
Yep.
So it's an unbelievable heat reservoir. And it's also what has prevented the planet to be much, much warmer than what we are feeling, because again, the water does not warm up as fast as air, and we have a lot of water that we can warm up. So it's been incredibly helpful in limiting the damage of global warming, if you
Yep.
want. But at the same time, is a huge reservoir of heat that at some point has to come out or has to equilibrate. So the good side is that 90% of all the heat that comes from extra trapping of solar radiation in our atmosphere and on our planet has gone into the ocean. The bad news is that the heat capacity is so large, at some
Mhm.
point, even if we stop tomorrow to emit, we will still warm up the planet for at least 100 years,
The-
because that ocean will release very slowly what has accumulated in order
yeah.
to go back to where it was, and it's going to take a long time.
So, to clarify some points there, when you talk about heat within the ocean, are you talking about the ocean, the water itself, or the elements of the ocean being the plants, the other life, or everything? I mean, yeah,
No, when I'm talking about ocean heat content, is really the heat, the joules of energy
yep,
that the ocean contains, because that water has a temperature. And so really the energy of the ocean in terms of heat, it's heat content.
yep,
Not plant involved yet.
yeah, right. Which is, I assume, where we start to talk about solution versus problem, but and maybe a segue. I mean, how what is the it's not an easy fix, and the oceans are huge and they're diverse and they're different in every part of the world, right? I mean, it really depends, and you have different streams of heat that run through those oceans. What are some of the solutions and models that you look at in terms of reducing this heat when you're doing it from within the ocean and not from within the atmosphere, which is also another way that we're trying to reduce carbon and reduce heat?
So when you're looking into the ocean, there are some of the solutions are very similar. There is the idea of just removing CO2 from the ocean directly. So carbon, at that point, is dissolved carbon.
Mm.
The problem with that is that you have to move water, and moving water requires energy. And so it's easier to move air and do direct air capture that it's to do direct ocean capture.
Mm.
So you have a lot of water and you have a lot of carbon, but it's expensive to move the water around. One promising avenue is alkalinity enhancement, where you are essentially distributing at the ocean surface a little bit of rock dust that is going, if it stays at the surface long enough, to take some of the CO2 from the atmosphere and transform it in carbonates. Once it forms carbonates, they're going to be heavy, they're going to be they will sink at the bottom of the ocean and that will stay there. And that is a very easy way to sequester if we are able to keep the initial dust near the ocean surface.
Mm.
So it's a matter of figuring out when is the best time to do that in different basins, what are the conditions under which that kind of 10 days that we need as it's going to be found, essentially. Um, Smaller scale, but still extremely useful, are restoring coastline, mangroves, so blue carbon, so essentially ecosystems that are going to just take down CO2 like plants do, and growing algae in the ocean to do exactly that in a fast fashion, because we can maybe distribute nitrogen and phosphorus to make it grow faster, and then we can sink them in a
Yeah.
controlled way.
What?
All of those solutions are expensive, and in a way, we are further in developing those solutions over land than we are in the ocean. There are
Yeah.
still a lot of uncertainties.
Yeah. That's what I mean. That was prompting the question. I mean, the carbon removal space, and we'll talk about removals. I mean, this is essentially, and tell me if I'm wrong. I mean, I see this as like with what we do with biochar and communities. It is part of the process, but it's almost a byproduct of the process, because in what we do, it's about social impact, it's about communities. I mean, ultimately, a lot of what you're doing in the oceans is about conservation and shifting things, right? The carbon removal piece is potentially, it's important, and it's a financing mechanism as well, hopefully, although we're seeing definitely challenges there. But is really conservation the main kind of driver here, with removal being part of the puzzle? How do you see it fitting together as a model commercially?
To be honest, commercially, I think there are kind of two separate parts and two separate problems. We are losing quite quickly biodiversity in the ocean, and we know that that is a major issue,
Yep.
and is a major issue also economically and for protein supply, because 1 billion people live out of proteins that come from the tropical oceans, and the tropical oceans are warming up, coral reefs are dying, and we need to find a solution for that. So conservation there is it's definitely very well justified and justifiable. And the fact that if you are restoring the reefs, you are also helping a little bit on the carbon drawdown, because you're going to have healthy ecosystems that are going to use some of the carbon that is dissolved in the water. That is true, but I think it's a minor advantage. At the same time, I mean, algae could potentially be part of the solution. The interesting thing about algae is that it's probably the only analog that we have for a solution that nature put us there, because in 2011 we start having a huge amount of algae growing Sargassum, so our floating algae that have been growing in the tropical Atlantic at around 10 north as a latitude, and they really extend from almost from the coast of Africa all the way to the coast of Brazil, and then they move into the Caribbean and into the Gulf of Mexico. We never had that kind of blooms of Sargassum, especially not in that region, and they are costing a huge amount of money to clean up from beaches. And they are taking down a lot of carbon. So
Yep.
the amount of carbon is significant, because it's such a big amount of material that is doing photosynthesis. And so, how to remove that before it gets to the beach and rottens? Um, because if it does that, it will release the carbon back to the atmosphere. It's an interesting problem that is getting attention, because our communities that are usually relatively, um, I mean, not especially rich, with the exception probably of the Gulf of Mexico or Florida, but you know, the Caribbean, the islands, the Central America. And at the same time, if they want to keep tourists along their beaches, they need to clean it.
Yep.
Right? So it's really a low-hanging fruit that it's 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 there, and it's a natural analog of what algae growth at the point of making a dent in the CO2 problem will look like.
And what is the process with that? So, I mean, that's essentially, when I look at the land version of that, that's like we deal with the crop issue, waste. So you're dealing with a waste substance within the sea. What is the right way to deal with that waste algae in a way that it does remove carbon and that the outcome is beneficial to both the ocean and the atmosphere?
There are different approaches, and I don't know if at this point we know exactly which one is best. My group with other colleagues at Georgia Tech, especially colleagues in mechanical engineering and in chemical and biological engineering, are looking at one possible way of using it, which would be collected and turn it into biofuels.
Yep.
Someone has tried also that in one of the Caribbean islands. It's very hard, or it's very expensive to convert directly sargassum into biofuel, because they are very high in cellulose and low in lipids. But they found that adding some leftover from the rum production, that it's typical of those islands, they can actually improve significantly the situation. We are looking to a different methodology that includes using potentially black fly larvae
Okay.
that will consume the sargassum, mix possibly to some other material like chicken feed. Um, so food that you will give to chickens. So a little bit of that and a lot of sargassum could potentially be a nice food for black fly larvae. And black fly larvae grow really fast and convert essentially the cellulose, part of the cellulose in lipids. They have a much larger, they break the cellulose and they have a large lipid content, so you can then use them to make the biofuel. Another solution that has been locally quite successful has been to use the algae to make building material, bricks. And then the big one, England the UK is doing a lot of research to figure it out, probably more advanced around Barbados to figure it out if that's viable, is to collect it and sink it. So to collect it at
Yeah.
sea before it gets to the beach and then sink it instead of letting it get and rot.
Cool. So plenty of options, just a lot of work to be done.
Yes. Yes. It's just a difficult environment, right? Because if
Yeah.
you sink it, over land, it's a little bit easier to figure out what is going on if you have a lot of leftover for crops.
Yeah.
But in the ocean, if you sink it, you have to put cameras, you have to
Yeah, right.
leave them there for like 6 months, you have to see what's happening. It's just a hard environment to measure.
Yeah, well, I mean, just look with this, with the removals industry specifically, where people are investing in these processes. I mean, access to data and transparency, and on land is hard enough. So when you start to go into the depths of the ocean, it definitely adds another layer of complication. So,
Yeah.
maybe a bit of a segue to a question. I suppose a step back, talking about the data, like in terms of looking at the oceans and what we know, and mapping the seas, and how big is the gap of understanding? How much more? I imagine it's vast in terms of how much more we could know versus what we know today, right? And is a big part of what
Yeah.
you do trying to just gain more and more insight and information into the oceans themselves.
Yes, absolutely. And we do it with model because that's a cheap way to do it. It's still very expensive to do observations, especially deep observation.
Yeah.
Since about 2000, 2002, we have a kind of floats which are autonomous, which are called Argo, which are fantastic, and they've really revolutionized the way we observe the ocean. Essentially, you drop them in the water away from a coastline. They will go down to about 2,000 meters or 1,000 meters. You can decide which one you want. They will stay down for about 10 days and then they will come back up. And while they are coming back up, they are measuring temperature and salinity, and in some case also oxygen and carbon concentration. But
Yeah.
the ones with oxygen sensor and carbon sensor are very few. And the moment they reach the surface, they communicate all those data to a satellite. And so in real time, you can have that column of water measured. And you also know their position. And so at least every 10 days, you know how much they moved. And we have about 4,000 of those at any time in the ocean since the early 2000s. So we finally know much better than we did before, almost everywhere in the ocean, how things move and temperature changes in the upper 2,000 meters. The problem is that the ocean on average is about 6,000.
Yeah, right.
So we're still missing everything else. And we have very deep currents, which are very important for climate purposes, that we are not measuring completely yet. We're doing a better job there as well, but still very limited because it's really expensive. If you want to do really deep work where you, for example, you send down a submersible to actually see what's going on, so also to discover ecosystems, to see new species of things, if you want to protect them, it's about $50,000 to $100,000 per day, depending on the technology you're putting down. And
Yeah, right.
submersible go down, but they have an autonomy of about 6 to 8 hours, and so it's expensive.
Yeah.
So it's still common to say that we know more about Mars than we know about our ocean because Mars is easy, right? I mean, you just have to observe the surface in a way. It's not that easy because you will want to know what's underneath the surface, but you can observe the surface of Mars almost as much as we have observed the bottom of the ocean because the kind of machinery that we have put at the bottom of the ocean are actually more expensive or equally expensive to the one we have to put at the surface of Mars.
For sure. And in terms of, when you look at when you're looking into those kind of depths below 2,000 meters, I mean, the the importance and the interest of that work, is it purely to learn more about our environment, or are there also risk factors that we can learn from going that deep, or essentially can we learn most of climate impact and other risks in the kind of top layer?
We can learn a lot about the top layers, except that the overall circulation of the ocean is linked to how water mixes, and water really mixes from 6,000 meters all the way up.
Right.
And so to figure it out, those processes that really have a strong impact on climate, we need to figure it out ocean mixing. And the other reason we would love to have better quantifications is that a lot of carbon is stored below 2,000 meters. And, it may be stored there for 1,000 years or 2,000 years, and that's great. But how it gets down there, and is there a way we can send it down there a little bit faster? That those become very important questions.
Sure.
So the carbon sequestration as well is an important area.
Sure. And then
there is all the marine.
Yeah, I was just going to say then, and the price for learning more at that depth is where it gets challenging then, because you're going below 2,000 meters. There's a huge price tag in terms of just doing the research and learning more when you get down to those depths. So,
yeah,
what
unfortunately,
AI has kind of hit the world by storm. It's been around a long time, but I think it's been in the public domain really 24 months. It's kind of gone crazy. And AI in your role modeling, when you're using big data sets, has AI been around a while? Are you finding AI is supportive in terms of the work you're doing, in terms of the modeling? Do you see big leaps being able to be made as we go forward?
Definitely big leaps in terms of weather prediction, which is very important also. And it's definitely important in the ocean. It's very important for all the coastal areas. A little bit less on the climate side. And the reason I believe is that, climate is it's an average over a long time. And what we want to really understand is how that climate is changing.
Yeah.
And so artificial intelligence is fantastic when you have data to train your artificial intelligence systems, but they don't necessarily extrapolate into an unseen situation, which is really what you want to do, which is the climate prediction. And so in the climate arena, what we are doing is using artificial intelligence to really help us build better models at the scale that we cannot resolve in our dynamical model. So we still use the old kind of models, the old style models, but those old style climate models have a grid, and that grid is 50 kilometers by 50 kilometers by, how many layers you put in the vertical. And so what happened in a 50 by 50 kilometer grid, it's all uniform and is what we say parameterized. So helping understanding those processes that ultimately are the one that impact also the large scale is where real artificial intelligence it's being used or tried and may be helpful. Extrapolating into the future is still something that I don't think we're doing currently. The problem is that, again, artificial intelligence is fantastic when you have data, and we have good climate data only starting in the 80s with satellites. And for the ocean, really only in the upper 2,000 meter and starting from 2000. So the record is relatively short.
Sure. And on the same vein of technology, and this might not be your area, so just tell me if it's not, but in terms of, looking at the other side, power generation, so replacing old energy systems with new energy systems, is that an area you get into? And, in terms of, things we can put on the ocean to generate power and you leveraging the
It's
power of the ocean.
definitely it's definitely not something I personally do, but I do have colleagues that have looked into that quite extensively, especially when it comes to tides or waves.
Yeah.
And in both cases, it's tough because it's hard to work in the ocean and keep equipment working properly in the ocean. So, tidal energy, there are a few regions where you could think of using it and using it with an advantage. So, you don't spend to run the instrument more than the energy you're putting out with it. But very few of those places are along the US coastlines.
Yeah, I've noticed some solutions here. Obviously, I'm in Southeast Asia, and I've noticed, things in Singapore that are being done. But I suppose a lot of it comes down to practicality of, literally where the ocean is in relation to, technology on shore and what can be done just geographically, right?
Yes. So, for example, in the US, one of the places where it would be energetically convenient, it's if I recall correctly, is around Alaska, but there you have weather issues, and so the deployment of instruments in a place that can get sea ice, it's simply cost prohibitive. Um, Singapore has very strong tides and is in a much easier climate and much easier currents if you want, so it's worth it. But there are not that many places. I think that the UK is doing a great
Yeah.
job with wind energy over the ocean, and probably that's the one that I would bet it's the most likely to work out. So using the ocean, but for the production of energy through the wind that just
Yeah. Yeah.
above.
Yeah, I mean, I'm from the UK. So I flew back twice this year, but when you fly into the UK, you see an increasing number of turbines out there on the ocean and stuff. So as we get towards the end, just going back to carbon removal and asking a few questions around removal, capture, and I suppose the first question, the gap between the work you do and the investor buyer community, and if it's even a gap that you're looking to kind of close, is that do you see yourself as being out there trying to provide information and insight to the investor community, or is a lot still need to come from governments and other areas in terms of understanding the oceans?
I think the ocean is a little bit behind compared to other land-based solution in that sense. So we still need a little bit more understanding, like basic understanding, before we are at the point of deploying. Some of the work we do is for a foundation that eventually would like to have a startup and look at some of those solutions from a you know perspective of starting a company and starting to deploy. Microsoft is extremely active in that
Yeah.
sense, in the ocean especially. But we have seen some big failures in the first attempts.
Yeah.
Um, and it's definitely not as simple, again, because of the impact that you can have and because of the currents and things move continuously. And so whatever you put in a place doesn't stay there. And so it's a little bit more complicated. So we are definitely behind. But we are starting to have, I'm working with a colleague, material doing at least a life cycle analysis for the Sargassum, for example. So, when you come to the stage of doing a life cycle analysis, you are much closer to have something that you can actually do in practice and you can sell
Yeah.
to a company, or you can have a startup. But we are probably a couple of years away.
Sure. Cool. Look, I didn't have any more questions, but I think to close, it'd be great to, where can people learn more? And I suppose two questions really. What advice would you give, firstly, to anyone wanting to understand more about the oceans in relation to conservation and climate change. And where can people learn more and find more about yourself or get in touch if they need to?
Sure. About myself, it's easy. I'm at Georgia Tech. They can look up my name, and there would be my webpage. And most of the things we publish and we work on, we work a lot on coral, for example, restorations as well, or conservations, how to try to preserve coral reefs, etc. When it comes to what people can do, I think that there are more and more communities, local communities, that offer, you know, tourism opportunities and learning opportunities in beautiful places to visit. They really make a difference locally, and they really teach a lot. So learning about what is sustainable from the ocean perspective, I think it's extremely important. Again, I would love to see the ocean to become more prominent in the carbon problem, in the carbon solution space. But I think that, again, we are behind, and I think there are very good reasons why we are behind compared to other solutions. In terms of conservation, I think it's extremely important that we start thinking about what we have lost already and what we really would like to keep for the future generations, because life in the water, it's most likely where it started, and we should try to consider that and keep it in mind when we go and mine or destroy ecosystems that are not coming back anytime soon.
For sure. And actually, just when you were talking there, I know that on a personal note, you're passionate about this space because you spend a lot of your time on the ocean, right? Sailing, and did some pretty big trips.
Yeah, before I had kids, probably more than now. But yes, I did love to sail, and it's an incredible experience. If anybody can cross an ocean on a sailboat, go out and do it. Because really it's just amazing. But yeah, I mean, just talking to local communities, fishermen, I find that fishermen everywhere, and definitely in the US, are among the communities that are more sensitive to the problem. They really understand, and they do understand what sustainable fishery means. Because they have seen it going down so much in the 70s and 80s, that they really know that there is a problem, and they are trying to work with scientists to find solutions. And in a lot of places is working. And so the beauty of the ocean is that you can almost completely destroy an ecosystem and then leave them alone for 3 years, and it comes back to levels that are unexpected. So, you can make a difference easily. In a way, you can actually see in your lifetime the difference that a sustainable practice can do. So that's important.
Cool. Look, Annalisa, it's been lovely to chat. I appreciate you sharing your expertise and time. And for anyone watching or listening, I'll leave the details for your website and other contact details in the notes. But yeah, appreciate you jumping on, and have a lovely evening.
Thank you. Thank you very much for having me.
Thanks.